The objective of this demonstration is to determine the chain rules for the three very frequent differential operations in vector algebra. One of them is the simple one, which is the gradients of a product of two functions, right? The other one is the divergent of a function times a vector, and the other one is the curl of a function times a vector. Okay, this one is very simple. Let's start with this one here. The gradient of a product of two functions. Well, if we use the representation for nabla in which repeated indices are equal to sum, so it's going to be something like this, and each of these is a derivative operation, a type of the derivative that depends on the coordinate system, but it's going to be something like this, right? It's a chain rule traditional derivative of a product of functions, f nabla ig plus g nabla if. Then what we have is simple, right? This is going to be equals to f ai nabla I times g applied operating on g plus g ai nabla I operating on f. So using the notation, this in fact is a sum in the three indices of I, which gives nabla, which is this one too is nabla. So that's what we get. The nabla of fg is simple, right? I mean, that's not a big deal to solve this one. F nabla g plus g nabla f. So that's the chain rule for the nabla of product, the gradient of a product of functions. Well, let's go to the second one here. The divergent of a function times a vector. Let's again use the repeated indices notation. We're going to have something like this. Dot, right? F, that's a AJ versor AJ. Now we can put this dot here, right? Put it like right there. It's going to be AI dot nabla I, which is a derivative operation. Let's make it like this: F times AJ. So we have a chain rule here. You can see these as two functions. This is a function, this is another one. The chain rule is very easy. AI dot, then we have a chain rule. Let's make it like this. First we do the gradient of this, and this passes along, passes to the other side. AJ dot, not dot, sorry. Nabla I applied to F plus F nabla I applied to AJ, okay? That's what we have. Then we go, this is going to be something like, I can put the dot over here. In fact, I can put the dot here and pass AI to F to the dot like that. So I'm going to make a dot product of AJ. I'm going to make AJ, capital A, lowercase a, dot, and pick a dot right here. AI nabla I applied to F plus, again, I pick the dot and go over here. In fact, not there. I put the dot right here. And AI puts over here. Okay? So it's going to be plus F AI nabla I dot AJ. So what we have here is the sum from J equals 1 to 3 equals to A dot nabla applied to F, which is the gradient of F plus F vector nabla dot vector A. Right? So that's the chain rule. The divergence of a function times a vector equals to A dot the gradient of the function plus the function times the divergence of the vector. That's the chain rule that we wanted to demonstrate. Okay. Now, the other one is going to be very similar to this one. We are going to make it on top of this one. I'm just going to erase some of the things I did here. Let me erase this thing here. You might have to be careful when you do that. Using the cross product, it's going to be a little different. So let's do the same thing. So this was the first one, right? This was the divergence. Now we want to do the curl. Okay, so what we're going to do is to follow the same steps. Curl of FA equals to AI nabla I curl of FAJ, which is equals to, I put this symbol here, right, instead of this one. Then what we're going to have is, let me erase this symbol here and put the other one, AI cross, okay? So we have, now the key step is in changing the position of this term here with this term here. You notice that before I could go to the other side, to the left side, without any violation, but not now, right? When I use the cross product, in going from here to here, I have to change the sign because the cross product is non-commutative, okay? And this one keeps, this one here keeps unchanged, okay? So we're going to erase this thing here and put the cross right there. So that's the only difference we have. So instead of doing the dots, we're going to have minus A cross gradient plus F curl of A. Okay? That's the result we obtain. So for the curl of F times A, we have the only difference minus A cross gradient of F plus F times curl of A. That's the chain rule for the curl of a function times a vector. So these are the demonstrations for today.